Welcome back to Mandem Academy, Mandem. So today we're going to be learning about creating the linear equation of a function from word problems, because word problems are honestly the killer of the Mandem. But first, let's just talk about linear equations in general. What makes a linear equation? So to make a linear equation, we need a constant rate of change. Constant rate of change because the slope's always the same. So the graph will look something like this, and the slope will be the same here, here. The slope will be the same everywhere. So how about some examples of constant stuff? Like imagine you're in a car and you're just cruising, like you're cruising on cruise control at 100 miles per hour on the 401, just cruising down the street in my 6'4", just like NWA, or you could just be walking through the ends, like looking to stain a man. You could just be walking at a constant rate of like 1 meter per second, for example. Or like you could be wake up in the morning, you have to brush your teeth, so you turn on the tap, and the water flowing out of the tap, as long as you don't turn up the tap more, the water flowing will be coming out at a constant rate. So how do we construct an equation of a linear function from a word problem? So there's two formulas that you'll be using. You could use your slope y-intercept form, y equals mx plus b, or you can use your point slope form, y minus y1 equals mx minus x1. But generally, for these ones, for a word problem, the slope y-intercept form will be the best. So let me use a different color. So just to recap, what does this represent? M will represent your slope, and B will represent your y-intercept in this equation. And for this one, a point on the line, a y value of a point on the line, so y value. M is still your slope. And then x minus x1, so the x1 will be an x value, a given x value. Alright, now we know that, so we're going to go through an example and we're going to use the slope y-intercept form to solve our example. Alright, so here we go. Trevor just jammed a Mayu and he's fleeing from the scene. Trevor's been to jail and he ain't going back, so he sprinted at a constant rate of 5 meters per second. Just take that in. Like, imagine 5 meters. 5 meters is huge, and he's going at a second because Trevor is not trying to go back to the bin. Like, he's running quick. Like, he's actually running quick. Alright, so back to the question. So he sprints at a constant rate of 5 meters per second to get a boy. Wait, Y is right around the corner, so Trevor only has 10 seconds to reach the getaway car and off it, or he's getting knocked. If the getaway car is parked 45 meters away from the robbery, will Trevor get latched? Part B, if Trevor remains at the scene for 3 seconds to snap the robbery and then offs it, will he get latched? And then part C, if an op is lurking 21 meters away from the robbery, how long will it take him to reach the victim if they run at a constant rate of 4 meters per second? What is the equation of the line modeling the op's distance from the victim and determine the domain and range? Alright, so we always have to illustrate these things and understand what's going on. So let's bust out a quick illustration. Alright, so here's this guy who just got jammed. Man has no money. Man's holding his pockets like he clearly just got jammed. Here's your boy Trevor. Man's running. Man just hit the stain. Oh, hold on. Let me give him some money. Jeez, yeah, he just hit the rude stain and he's running to the getaway car right now. And there's the boy lurking. So first of all, we're gonna answer part A. So Trevor's running at a rate of 5 meters per second, and he's 45 meters away from the car. So let's draw 45 meters from the robbery to the car. 45. Alright, so let's make it first we have to make an equation for Trevor's running. So we're going to use our slope y-intercept form. So y equals mx plus b. In the question, the change in speed will always be your slope in a linear equation. So for slope, we can easily just sub in 5. 5x equals plus b. So what will b be in this situation? So let's think about this logically. The y-intercept, where does the line of this graph hit the y-axis? So it will hit the y-axis. So if Trevor starts running right away, Trevor started at 0 meters away from the robbery, and Trevor has been running for 0 seconds. So obviously the y-intercept would be at 0. So we don't even have to put it. So the equation for this line would look something like y equals 5x. Pretty simple. Alright, so now we know that Trevor has 10 seconds to reach the getaway car and off it, or he's getting off. And the getaway car is 45 meters away. So Trevor has to run at least 45 meters in 10 seconds. So now, since we have time, which is our x value, we can find our y value. So we can just sub in y equals 5 times 10 seconds, because he's running 10 meters per second. And then we can go y equals 50 meters. Alright, so if Trevor runs 50 meters, since 50 meters is greater than 45 meters, clearly he can get away. So Trevor's blessed. Trevor's off this with his nice money, and he's hopping in the whip and he's skirting. Alright, so that answers. So let's formally answer this question because it's a word problem. So therefore, Trevor ain't getting knocked. Alright, and that answers part A. So now for part B. So Trevor never do this. I don't know why mans do this. Trevor clearly wanted Raiden. So now he wants to snap the robbery, waste 3 seconds to off it. So he might get latched. He's wasting time. So now he has 3 less seconds. So instead of 10 seconds, he has 7 seconds. So now we're going to just use our same equation that we just created, y equals 5x. And we're going to have to sub in 7 instead. 5 times 7. 5 times 7 equals 35 meters. Oh man, it looks like a man like Trevor's getting knocked. Like, see, that's why you don't snap for Raiden's, fam. Like, if you're gonna hit the stain, just hit the stain and off it. Because now Trevor's gonna go to the bin. Man has a criminal record. His life's changed because he could only run 35 meters and he needed to get 35 meters. And you already know his real man isn't loyal. His real man is off this as soon as he sees the boy catch up to him. So so look at Trevor. Trevor messed up, yo. This Y, we're just gonna move him over here. The boy is like, yo, you're under arrest, you're under arrest. Da, 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 da. Yeah, he's under arrest, bro. He's under arrest. And Trevor's not going to the bin. Alright, so now for part C though. So now we're gonna now we can look at part C. So sorry, I found a little typo. It's not supposed to be 21 meters, it's supposed to be 24 meters actually. So now we can do the question with this adjustment. So let's draw it out. Okay, so we have the op and his distance. He's posting up, he's lurking 24 meters, and he's 24 meters away from the crime scene. So then we can answer this question. So what do they want? What's the equation of the line modeling the op's distance from the victim? So let's create the equation of this line. So C y equals mx plus b. Y equals, so let's scroll up and take some information from the question. So it gives the speed a constant rate of 4 meters per second. Speed, like I said in these linear questions, is always going to be your slope. So 4x plus b and b. So let's try and think about this logically. So the y-intercept is when x equals 0. So when 0 seconds have elapsed, where is the op standing? So right now, this drawing denotes the situation that I'm talking about. So 0 seconds, the op's still 24 meters away from the crime scene. So this would be 0.024. Therefore, we can say that the y-intercept is going to be 24. So we can add that into our equation right down here. 24. Okay, so now that we have 24, there's one more key that we have to do. See, because the speed, we have to say that it's negative because the op's running towards the crime scene. See, Trevor's off this. Trevor's running a positive direction. Trevor's running this way. Trevor's off this to the getaway car. But the Y, he's trying to get a statement, so he has to run towards the crime scene and help the little Mayu that got jammed. So since he's running towards, we just have to add an extra negative in front of our equation. Boom, negative. Now our equation's done. Let's rewrite it, make it look a little better. 4x plus 24. So next the question asks for the domain and range. Hold on, let's box this. Next the question asks for the domain and range. So domain, range. It sounds complicated, but it's a pretty easy concept to grasp. So basically the domain and range is just that like the reality of the situation. So there's certain things that can't happen in real life, like negative numbers don't happen in real life. You can't have -5 seconds in real life, or negative distance away from something. You can't really have those things in real life. So it's just asking for the reality. So the domain is always with respect to the x value. So domain, you write XAR because it's a member of the real numbers. And then we say that what's the lowest possible number that x could be in this situation. Of course, it's 0 because 0 is the lowest possible time we could have. And then what's the highest possible x value? That would be at once he arrives to the crime scene, where there's no more distance because there's no negative distance, so he can't go any farther to the crime, any closer to the crime scene. It's already 0. So now we have to calculate that with our formula. So y, so when y is 0, because we want to know once he gets to the crime scene, how long does it take him to get there? What will x equal? 4x plus 24. Now we can use a little bit of algebra and solve for this. So 4x plus 24, so we can move the 4x over, and the 24 is over here, and then we divide by 4. X equals 6. Yes, x equals 6. See why I had to change it to 21, because 21 is an ugly number to divide by, so we have to make it 24. Now it's a good number, so x equals 6, so we can edit our domain and range. Finish it off. So 6. And remember equal to 6 as well, because it can equal 6, because once he gets there it's 6 seconds. So now we have to do the range. So what's the maximum distance and the minimum distance away? This is pretty easy. We don't even have to do any calculations for this. We just have to think of it logically. So logically, the closest he can be is 0, and the furthest he can be is what he started at, 24. And there's the domain and range. So our question's done, and I hope I helped out you guys. This helps you guys out a lot. So the key to the story is, if you're gonna rob somebody, don't snap it for ratings, because you're gonna get latched, and don't get caught slipping by Trevor, because Trevor's fast. Trevor will catch up to you. But if there's any questions about what I did here, you can just leave it in the comments. I'm here to help. And don't drop out of high school. I'm gonna get you guys through high school. Don't worry, you guys will make it, fam. You guys will be good.